You will need your notes from yesterday too, so we can finish that last example problem on there.
Can I get a pencil real quick?
On yesterday's paper, we reviewed about how to factor, specifically using the star method. Okay. We learned how to factor using the Xbox method as well, but the star method really does have more benefits to it, and I will show you at the end of our notes today why that is. Okay, and that's why it's the one I prefer. So when that you take the STAR test, you will get one of these papers. Okay, these are allowed for the STAR test. Okay, you should have one inside your journal on the front flap that I gave you at the beginning of the year. If you don't, then I can get you one, or you can have one of these full-size ones. That's fine. But when you get this on the STAR test, you can't start writing on it before you're told that you can start writing, okay? But before you start answering any questions, we're gonna practice this before the start. I want you to do what's called a brain dump. Goodness. And what that means is anything at all that you remember learning about anything, shortcuts, anything, I want you to write it on this paper or write on the back of it. Make you a note somewhere so that when you come to that kind of a problem and you get a brain fart and you can't remember anything, then you have something that you can look over and go, oh yeah, that'll help me right there. Or maybe that'll spark something for you to remember how to do. Does that make sense? And so if you do that at the very beginning, before that you get brain fog and forget stuff, then you'll have a reference to look back on and hopefully help jog your memory when the time comes that you need that on the test. Okay, so this is one of those things that you should write on there. Okay, as soon as you get it and as soon as you can start writing on it, this is something that you should write on there. I can't remember if I told this class or not yesterday, but factoring falls under two categories depending on how the question is worded. It either falls under category 1 because it is multiplying two binomials together or dividing, okay? Which falls under category 1. Or if you're solving for a quadratic, then it falls under, I think, category 4. Okay, so this actually falls under two different categories. So it's actually weighted pretty heavily on there. Same thing with range and domain. If you do not remember what range and domain are, you need to get those memorized. That falls under almost every single category, whether it's range and domain for linear, range and domain for quadratic, range and domain for exponential. Range and domain are a big portion of the test as well, okay? So those are some big things to pay attention and for sure know those vocabulary words. That's another reason why I'm harping on vocabulary, because half the battle is just knowing what the question is asking, right? Okay, and that's a lot of vocabulary. So the STAR method. So back to yesterday's paper, example 6. And what's the very first question that you need to ask yourself if that we want to solve this with factoring? Does it equal 0? So does this equal 0?
No.
No. Okay. So to get it to equal 0, we're going to have to subtract 5 from both sides. Okay. That cancels out, makes this side equal 0. And we've got 3x squared doesn't change. Negative 16x doesn't change. And negative 7 and negative 5 becomes negative 12. Is there a greatest common factor between 3, 6, and 12?
3.
Does 3 go into 16? Mm-mm. So it'll go into 12, but it won't go into 16, and 2 doesn't go into 3, so there's not going to be one, right? So there's not a greatest common factor, so we're going to go right into making our star. What am I going to put on top?
Wait, no. 8 times.
So 3 times
12?
Negative 12, right? We want to include the sign. Okay, so 3 times negative 12 becomes what?
Negative 36.
Negative 36. And what goes in the bottom?
16.
Negative 16. Okay, what else do I know that I can put in my star?
On the sides.
On the sides, what goes there?
3.
Okay, 3 and 3. So now I'm trying to figure out what my 2 missing things are. So I need them to multiply together to give me this number at the top and add to give me this number at the bottom. What does the top number being negative tell me?
That one's going to be positive and negative.
One's going to be positive and one's going to be negative. So let's see, we've got negative 36. I know because this one's negative, my bigger number side has to be negative, right? So positive 1 and negative 36, does that equal a negative 16 when I add them? No, okay. So then I've got positive 2 and negative 18. Does that add together to give me negative 16?
Yes.
Okay, so 2 and negative 18.
Where do you get the 18 from? Like from the 36?
So take your number that you're trying to. So this is why I always start with this side as I list, because 1, so negative 36 divided by 1 is negative 36. Negative 36 divided by 2 is negative 18. So if you don't know, then you can divide. So if you go down and just count 1, 2, 3, divide in your calculator and see if you get a whole number. If you get a whole number, then it's a possible combination. And if it works to add together to give you that bottom number, then it's your one that you're looking for. Does that make sense?
Mm-hmm.
Okay. So that's how I do it. That's why I go in order so I don't miss something as well. That's why I go 1, 2, 3 until I run out of numbers. Okay. So now reduce. Does 3 over 2 reduce at all? Is that going to reduce? So that's going to be one of my factors. 3x plus 2. Okay. Top one goes with my x because it came from my x squared. Right? So it goes with my x. Okay. What about 3 and negative 18?
You reduce 1 over 6.
They'll both reduce by 3, so it becomes 1 over negative 6. Okay, so I'm going to use this one now. take my other one. So x minus 6 still equals 0. So what's my next step? I've got it factored.
To reduce them? Yeah.
So separate them, right?
Mhm.
Separate them. So 3x plus 2 equals 0. And then 6 minus 6 equals 0. I'll finish solving for both of them. So this one is x equals negative 2/3. And over here, get x equals positive 6. So my two possible solutions are x equals negative 2/3 or 6. Okay. Remember that solutions, zeros, roots, x-intercepts, all are talking about the same thing. Okay, that's another big one to know. Zeros, x-intercepts, roots, solutions, all the same thing. So that might also be something you write on the corner of your paper, right? When you get it, so you can remember that when it comes time. Okay, so now to today's notes. Okay. I'll try to get through this fairly quickly. For one, all of our examples are already equal to 0 for us, right? So that starts us off already on step 2, right? Are any of them factored for us? No. So we're going to have to factor all of them. Okay. Is there a greatest common factor first on this number 1? Take the smallest number there. Does it go into the other numbers?
No. Wait, yeah.
So that means it'll factor out. Okay. That doesn't always work. Like if the smallest number was 6, then there would still be a greatest common factor, right? But 6 wouldn't be it. But always start with your smallest number and check it out first. Okay. So 3, if we divide everything by 3, then we would get x squared plus 3x minus 4 still equals 0. Okay. We don't technically have to do it to both sides, but 0 divided by 3 would still be 0, right? Because all I'm doing is making it the same thing. I'm just putting it in a different format. So I'm not moving things from one side to the other, so it doesn't have to be done on both sides. Does that make sense?
Yeah.
Yeah, kind of. Okay. So what information am I going to use in my asterisk?
Wait, I have a question.
Yes, ma'am?
So when you factored it,
Mm-hmm.
since you got -4, is it because you multiplied 3 times -12?
Well, I didn't. I divided.
Yeah, divided it.
Negative 12 by 3. Yes. So what's going to go in the top?
3 times 3 and 3 times.
From -4?
Well, not 3, because my 1 is actually right here. I mean, my A is actually 1 right there, right? So the 3 just comes down to be put in front of whatever my factors are going to be. Okay, but it's not my A anymore. So -4 times 1 is what?
-4.
Is -4. And then what goes in the bottom?
3.
3. And on my sides?
1.
So what are my factors that are going to multiply to give me 4 or -4 and add to give me 3.
-4, and 1.
Yes, but if I have -4 and +1, am I going to get a +3?
Yes. No, so it's +4 and -1.
+4 and -1. So +4 and -1. Because my bigger number should be whatever sign my bottom is. And that's always true, even when they're the same sign, technically, right? Your bigger number is always going to be the same sign as the bottom. So, do these reduce at all? No. So I've got x plus 4 and x minus 1. So separate them. X plus 4 equals 0. X minus 1 equals 0. X equals -4. And x equals 1. Now remember we said yesterday, it doesn't matter which order you put them in the braces, as long as you have both of them listed with a comma between them. Most of the time it will say your zeros are, and it will tell you the numbers, or your solutions are, or it might say your x-intercepts. It probably say roots, your roots are, okay, those type of things. And it won't necessarily list it like this, but occasionally it does. So that's why I want you to know what that means. Okay, be familiar with it. Okay. And then yesterday, we substituted things back into the calculator, right? So I'm going to do that really quick, just to okay, so in the calculator, I'm going to go back to my original problem, and I'm going to do 3. Always put the parentheses, -4, okay, whoops, squared, so 3 times -4 squared plus 9 times -4 minus 12. Where do I find the equal sign?
Oh, right there, over there.
Right underneath the control right here. So equals 0. Okay, I'm going to get true. Now, here's what I want to point out. If that you don't put the parentheses here, okay, all I did was forget my parentheses. Did I still get true? No, because with the parentheses, okay, it tells this squared to square -4. Without the parentheses, it only squares the 4. It doesn't square the negative. Okay, so make sure when you're checking your answer that you include a parentheses around whatever it is. And when you're checking 2 answers, okay, you don't have to type this whole thing again. Go up and highlight it and hit enter, and then just go back and replace whatever you need to replace. Save yourself time. Okay, so now I want to put in a 1. I'm still going to put it in parentheses just to make sure. Okay, so yes, both of my solutions work. These 2 true answers are the ones that I want to see, right? And so that's how to check it on the calculator to make sure that you get your right answers. Okay, so look at example number 2. Okay. Is there greatest common factor in this one? Yeah. What is it? 5. So then if I divide everything, okay, so if I say that 5 is my greatest common factor, that means I'm going to divide everything by 5. So 5 divided by 5 is 1, so that's why I have x squared. Okay, and negative 20 divided by 5 is negative 4x, and negative 60 divided by 5 is negative 12. Now I can do my star. Oh, it's going to go in my top. Negative 12. Change that. Negative 12. What's going to go in the bottom?
Negative 4.
Negative 4. And on each side?
1 and 1.
1 and 1. So now what numbers are going to multiply to give me negative 12 and add to give me 4? Negative 4, sorry.
Two and 6.
2 and 6.
Negative 6. So
Neg-
1 positive and 1 negative.
Okay, one's positive and one's negative. So negative 6 and positive 2.
Yes.
Okay. So now, do these reduce at all?
No.
Nope. So I still have the 5 out there. Okay, and x minus 6 times x plus 2. Notice that in the last one, and again in this one, I'm not going to do anything with that 5, and I didn't do anything with the 3 in the last one. Why did it not matter? I mean, I factored them out. They are one of my factors, but when I go to solve, I didn't use it to solve anything. If I write and take it, since it's a factor, and separate it and do 5 equals 0, does that make sense? Will 5 ever equal 0? No. Okay, if there's no variable that you factored out, then it's not going to matter. Okay, substituting something in, there's nothing there to substitute in with your 5 to make it equal 0. Okay, had we factored out a 5x, then we would have something to solve for. But because it was just 5, okay, we don't have anything that we need to solve for it. We just need to do the ones that have an x in them. Does that make sense? So add 6 to both sides, subtract 2. So x equals negative 2 and x equals 6. We have 2 more examples to get through really quick. Is there a greatest common factor in this one?
Yeah. No.
No, right? They're all prime numbers, right? 2, 3, and 5 can't be divided by anything else. So now we just go straight to my star. What's going to go in the top?
Negative 10.
Negative 10. Because I'm going to multiply 2 times negative 5. What goes in the bottom?
3.
3. And on my side is going to be 2. This is the first time that it's not a 1 for us. So now I need 2 numbers. Multiply to give me negative 10. Add to give me 3. We've got 1 and 10. Is that going to work? No. 2 and 5. Is one of them supposed to be negative?
Yes.
Okay, so which one?
The 5 is positive and the 2 is negative.
The 5 is positive and the 2 is negative. Can we reduce 2 over negative 2?
Yes. 1 and over negative 1.
1 over negative 1. Okay, so this is what I'm going to use now. So I've got x minus 1. Okay, can 2 over 5 reduce?
No more.
No, so it's going to be 2x plus 5. Separate them. So this is where I'm going to explain to you why that I like the asterisk method. And then we're going to use this shortcut for the last example. Okay. What do you notice about this? If I were to simplify 1 over 1, what would it be? 1. Right? But if I simplified what's over here, right, it would be negative 1. And my answer is positive 1. So it's the opposite. Well, let's look at this one and let's compare this one to the answer that I get right here. What do you notice about it? Okay. They're both a fraction technically. Do you see a pattern? Are they the same numbers?
Yeah, but one's not. They're switched.
They're switched. And what else is switched?
The positive and negative.
The positive and negative. So if you use the star method, not only can it factor it for you, but it also solves it for you as long as you realize that it is opposite. Okay? Opposite sign and flipped. Okay? So your solutions are whatever your factors are, and your ratios, change the sign and flip them. Okay? So change the sign and flip them. And you will have your solution. Okay? So let's use that strategy when we do this one. Okay? There's no greatest common factor, so I'm going to go straight to my star. What's going to go in the top?
Eight.
Times 5.
Oh yeah.
So 40.
40. Okay, and in the bottom?
Negative 22.
Negative 22. And on my sides?
8.
Okay, 8. And my two numbers. Okay, this is a positive up here, which means both of my numbers have to be the same sign as my bottom one. And since my bottom one's negative, both my numbers have to be negative. So what are going to multiply to give me positive 40 and add to give me negative 22? Negative 20 and negative 2?
Yes.
Do these reduce any? Does 8 over negative 20 reduce any?
I mean, yeah.
Yes, 1/10.
Not 1 over
Oh,
10.
no.
They'll both reduce by 4, which gives me 2 over -5.
Yeah.
Okay, and over here, 8 and 2 will both reduce by 2, which gives me 4 over -1. So here's my 2 solutions. What am I going to do? So x equals, for this one, I'm going to change the sign. So instead of negative, it's going to be what? Positive. And I'm going to flip it upside down. So instead of 2 over 5, it's going to be what? 5 over 2. Okay, and then here for this one, okay, instead of a negative, it's going to be what? Positive. And instead of 4 over 1, it's going to be
1/4.
1 over 4.
So you don't take the negative sign with it?
You got to change the sign. So if it were positive, you would make it negative for your answer. Because when we're solving, right, when we solved these, okay, when you're undoing the process, right, that's where the sign change happens, because when you're solving, you're working it backwards, right? So that's why your answers are backwards from what your would have been in your factors. Does that make sense? Because when you solve it, you work everything backwards to undo your process. Okay? So you do not have to use the shortcut. You can solve them all like we've been doing. You can use the shortcut as well. So if you haven't done yesterday's assignment, now that you know how to do the shortcut, as long as you're showing me your star on your paper, that's your work for me. Okay, then you can give me your solutions. Okay, but I have to see some work on there. If I just see answers, I'm going to assume that you used a cheat app, and that's not going to help you at all on the STAR test. Okay, so that's why I need to see some work. Okay. So this whole paper is homework. Yesterday's paper, again, was just evens. Okay, so you didn't have to do all of yesterday's. Okay, this one, you do need to do all of. Everything is due tomorrow because it's the end of the 6 weeks. Okay. So if for any reason you cannot get it turned in to me tomorrow, I won't accept it after school starts on Monday. So bring it to me first thing in the morning, because my grades are due by the end of the day. Because I have to look over these, I need some time to do so. If you bring it to me after school, then it makes it hard for me to get it graded on time for grades to go in. Okay, so